So this is the video for 3.4. In it we're going to do one problem, question number 26, just kind of go through the process that you'll learn in class. Here we have a 3 by 3 system, meaning we have 3 equations, 3 variables, and our job is to find the answer. So our answer should come out with an x, a y, and a z. So we're looking for an ordered triple is what it's called. We want to know what point satisfies all 3 equations. Essentially, this is like asking where in space do 3 lines meet. This is actually really important because this is used for things like triangulation and finding things via GPS and other things like that. It's not good enough to know how far left and right to go and how high or low to go. We also have to know how far forward or backward to go. So there's 3 dimensions in our motion, and we need to know about each of those. And that's what this is going to allow us to find. I'm going to number these. I'm going to label them, 1, 2, and 3. Those are equation numbers, if you will, so I can talk about which equation I'm talking about. The next thing we need to figure out is which variable do we want to get rid of. I think y will be a little tough because 2, 3, and 5, 15, 30. 30 is really the common denominator there of those numbers, and that would take a lot to work with. I don't want to deal with anything that big. Over here, 2, 3, and 1, they all go into 6. That's not bad. 4, 1, and 1, they all go into 4. I actually like the x's best. So what I'm going to do is I'm going to choose to get rid of the x's. Now I can pick any 2 equations I want. I can pick the first and the last, or the first and the second, or the second and the last. It doesn't matter. Right now it looks really nice with 2 and 3, so that's what I'm going to do first. I'm going to write down equation 2 and equation 3, which is x minus 3y plus 2z equals negative 6. And equation 3 is negative x plus 2y minus z equals 3. Be careful that your z's don't end up looking like 2's. That can cause you some grief. If I add the 2 equations right now, the x's are going to cancel. I'll get negative y plus z equals negative 3. And I'm going to call this equation number 4 because it's a combination of 2 of the other equations. Now I need to do this again. I need another equation where there is no x, but I can't use 2 and 3 again. I either need to use 1 and 2, or I need to use 1 and 3. It makes absolutely no difference. But since 3 has a negative x, and this is a positive 4x, I like that combo. So I'm going to do 1 and 3. And equation 1 is 4x plus 5y plus 3z equals 15. And down here I have negative x plus 2y minus z equals 3. Well, if I tried to cancel right now, if I just added the equations, I wouldn't get the x's to cancel. And that's because 4x minus 1x is only 3x. So I need to multiply the second equation by 4. And I actually might move that over. Let's put that on the other side real quick. Put that back. I'm going to stick the 4 right here. Okay. The 4 would need to distribute into the parentheses. Now I could write each step down, or what I'm going to do is I'm actually just going to go through and do it as I go. We're going to use a little mental math. 4 plus 4 times negative 1. Well, 4 times negative 1 is negative 4. 4 plus 4 is 0. So the x's get canceled. 5 plus 4 times 2. 4 times 2 is 8. 5 plus 8 is 13y. Now, if I was struggling with this at all, I just grab my calculator, and literally I would type 5 plus 4 times 2 equals 13. So let's try the next one. It would be 3, because that's 3z, plus 4 is my multiplier times negative 1 equals negative 1. Well, this is negative 4. 3 and negative 4 is negative 1z equals 15, and 4 times 3 is 12. 15 and 12 is 27. I'm going to call this equation number 5. Well, the nice thing about 3 or 4 and 5 is that now I have an equation set, 2 equations with 2 variables. This is just like what we did in 3.2. Now I'm going to combine these. I'm going to put 4 and 5 next to each other and look to see if I can cancel them. Number 4 is negative y plus z equals negative 3. And number 5 is 13y minus z equals 27. Now, coincidentally, these z's cancel. Oftentimes they won't cancel right away, but in this case they do, which is just convenient. The y's turn out to be 12y. The z's cancel, and I get equal to 24. If I divide by 12, y comes out to be 2. There's the first piece of my ordered triple. So I can come up here, put a 2 between 2 commas. But I still need the x and the y. Now if I had to restart this process from scratch, this would be a horrible process to go through. But the good news is I don't, because equation 4 and 5 I could use with my y to find z. So let's take negative of y, which is 2, plus z equals negative 3. So I'm going to substitute my value right here. To move it z alone, I would add 2, and that would give me z equals negative 1. Well, now I know that the z is negative 1. All I need left is to find the x. And because I know y and z, I can go to any one of these original problems to solve it. I like equation 2. You know, it's one that has x as a single x. So I'm going to say x minus 3 times y is 2 plus 2 times z is negative 1 equals negative 6. This becomes x, this is a negative 6 and a negative 2, that's minus 8 equals negative 6. So I add 8, and I get x equals 2. My final answer would be 2, 2, negative 1. The biggest issue is probably in creating equation 4 and 5, making sure we don't make any mistakes. Again, make sure you're canceling the same variable both times. If you do x over here and then over here you decide to do z, you will get nowhere. There will be almost no progress made there. So I'd strongly encourage you to make sure you follow that pattern, pick a variable and stick with it. Good luck, and we'll see you in class.